Hello class, happy week 10. I'm officially on spring break here with 3 kids at home. So it's a little chaotic here in the Balchers household. Obviously on spring break too, got the t-shirt on, no bow tie. Things are a little laid back this week and not going anywhere this break, primarily because living here in Okinawa, it's kind of a vacation town more than anything, so there's plenty of things for us to do. And if you've never been here, I really do encourage it. It is a really cool, special place. Anyhow, week 10, we have our critical article review assignment this week. Again, you can either do nothing and get the 85, or try to beat that 85 and write a spectacular critical article review with the potential of doing worse as well. So your call. Use a little grade calculator from the beginning of the class and make that calculated judgment. Anyhow, we're moving into the chi-square test statistic this week. Just so you know, conceptually, the chi-square it deals with categorical or qualitative data, usually 2 variables with 2 or more levels. With that data arranged in a contingency table, meaning contingency table is a table with columns and rows with 2 or more columns or rows. I will give you an Excel workbook, and as well as the website that's linked below is a great way to run that statistic. And in a nutshell, you would have some sort of question, research question, collect data, whatever, on those 2 variables and create your contingency table with what's called a contingency table. And that contingency table is then you extrapolate and calculate what's called your expected frequencies. All right, and then from those expected frequencies, you would then calculate your critical value, compare that against the table value, and also have a calculated p-value, which you compare against a decision ruled table value of 0.05 or 0.01, depending on your level of precision, and make your decision to accept or reject the null hypothesis. Okay. With that said, on homework number 5, again, it's going to be a quiz-based set of questions in Leo. Questions 6, 7, and 8 have to deal with a specific contingency table and series of chi-square questions. And in my professional opinion, it's a very poor set of questions. It's actually inappropriate. The data, so you know, the question deals with the days of the week, so Sunday through Saturday, and the number of days sick for employees, and it's actually not categorical or qualitative data, so it's not when you would use a chi-square. So just going to tell you now, question 6/5b, the chi-square value is 0.80. Question 7, the critical value is 11.070, and question 8, the calculated p-value is 0.977. With that question realistically would be better off actually with a t-test or f-test. Number of days sick is not a categorical or qualitative data element. It's quantitative, it's a count. So just so you know, now you know. But the homework number 5, there's a lot of questions on chi-square. That should help you. There's a lot of questions on regression, which we'll get to as well. Again, they're not that hard. And then the rest of the content for this week has to deal with 1 and 2 tailed tests. And I don't know if I got into this too much, but the difference between 1 and 2 tailed hypothesis tests. Okay, when we talk about tails, we're talking about the tails of the normal distribution or bell curve. A 1-tailed test is a 1-tailed directional hypothesis. That's basically saying your null hypothesis, I always tell you that there's no difference, but if you have a directional hypothesis, meaning something is greater than some threshold or less than some threshold, then you're implying a direction or a tail. So if you're implying that something usually goes down or is less than, that would be a left-tailed test. If you're implying that something is increasing or above some sort of threshold, that would be a right-tailed test. Those are both single or one-tailed tests, okay? A two-tailed test is a non-directional hypothesis, meaning you're just interested in if there's a difference in something. It could be positive or it could be negative, and that's all it is. So do you understand that logic? That makes sense. In the case of the two-tailed test, that's where that concept of no difference, null, really, it makes more sense, because you're not implying any direction. You're just saying there's just no difference at all. So that is it. Chi-square, I'll float you to the table. You got the website. You know, it's an analysis of categorical data using contingency tables. You're calculating the expected frequencies and looking at the critical value and as well as the p-value. So that is it. Let's have a great week. Any questions, just ask.